Alright, this is the section on 5.1, Proving Identities. This is the second part of that lesson, and what we're going to do in this part is we're going to do a couple of more examples, some of which are a little bit more difficult. Okay, so here, let me lay out the general guidelines once again. We want to pick the ugliest side, so pick the side that looks the most difficult. We're going to try to change all the functions on that side to sine and cosine, and only work with one side at a time. So let's go down here and look. When we're doing an example like example 3, we definitely have a side that looks a lot uglier in this one. Okay, and so when we've got something like this, what we are going to do is we're going to end up trying to use a couple of little tricks. You may not know these tricks yet, but that's okay, because when we work with these tricks, I'm going to show you how to use them, and then we'll be able to go back and use them again later. The trick that we're going to use today is we're going to learn how to factor. So when we look at cosine to the fourth t minus sine to the fourth t and put it over cosine squared t, what we are going to do initially is we're going to go ahead and factor it. And so I preemptively drew these. I'm going to get rid of those because we're going to need a little bit more room. I'm going to reverse factor this. And what I'm going to end up with is cosine squared t plus sine squared t. And I'm going to be multiplying that by cosine squared t minus sine squared t. Okay? So notice I've got a plus and I've got a minus here. And on the bottom I'm going to have cosine squared t. Alright, let's take a look here at what this actually means. When I've got one side that I'm working with, what this is going to allow me to do is look at it and say, well, do I have anything that can be reduced? I don't know if you recognize this here. This is one of our Pythagorean identities. We talked about these in the last section of this video. Okay, so this is a Pythagorean identity. So this is actually equal to 1. So this is going to be 1 times cosine squared t minus sine squared t. On the bottom we still have our cosine squared t. Okay, so let's look at how this can kind of pan out for us. What we're going to do is we're going to divide this fraction in half. So we're going to have cosine squared t over cosine squared t, and we're going to subtract sine squared t over cosine squared t. We divide up the numerator and put it over the same denominator. So this is like when we have fractions, we have to have common denominators to combine them. So this is what we've got. So this right here is going to be equal to 1, and this is going to be minus, and we recall that tangent theta is equal to sine theta over cosine theta. And so this is going to be tangent squared theta. And if we see what we end up with after we reduce, it's actually what we wanted. Okay, so tangent squared theta, 1 minus tangent squared theta is equal to 1 minus tangent squared t or theta. So we're done there. The trick here was the factoring, then the splitting of the fraction into two pieces. Okay, so let's go down to example 4 and look and see what we've got. Obviously, this looks like the more difficult side, and so that's the one we're going to work with. I've actually made a little bit of a mistake here. This should be a plus sign. So when you're writing that down, make sure you write that down. That's a plus sign. Okay, so this is, let me rewrite, 1 plus cosine t is equal to sine squared t over 1 minus cosine t. Now, when I'm doing this, my goal is to get everything in terms of sine and cosine. I already have everything in terms of sine and cosine. And so what I need to do is I need to realize I may have to enlist a different trick here. I notice that I've got a sine squared t up here. To me that seems sort of odd, or like something maybe I could change. And so what I'm going to do is I'm going to look to a Pythagorean identity, and I'm going to say that that's actually equal to 1 minus cosine squared t. Because I'm going to try to match it with the bottom. Okay? And so let me rewrite. 1 minus cosine squared t over 1 minus cosine t. I'm pretty close here, because what I can then do is I can just do a little sidebar here, and I can make this one minus cosine t times 1 plus cosine t. Well, on the bottom I still have 1 minus cosine t. And look at what I can do here. If I'm multiplying up here, now, that's a distinction. In the last problem I had to split it because it was adding up top, but this is multiplying, and so I can cancel these out. And so what I end up with is 1 plus cosine of t on top. I factored it out. How can we remember this? Well, really, if I have this minus sign, I know that when I factor it, I'm going to get a minus and a plus term, and then I can cancel, and so I've got 1 plus cosine t is equal to 1 plus cosine t. That's done. Okay, so I factored that out. That helped me right there. All right, take it for face value. Try to get it down. See if there's a situation where you can use it. Let's look at example 5. Example 5 is kind of unique. It's not like something that we've necessarily seen before. And so when I've got tangent x plus cotangent x is equal to secant x times cosecant x, it may not be a situation where we know which one is more difficult. So let's do this. I am actually going to pick this side to stay the same. Okay? But what I'm going to do is I am going to say I'm going to keep this side the same, sorry, because this is multiplication. I'm going to pick this side because it has the addition sign. So what I'm going to do is I'm going to rewrite. And when I come down here, this is actually going to be equal to sine theta, or t. Sorry, let me keep it consistent for you. I don't want to confuse anybody. So this is sine t, actually x in this case, over cosine x, plus cosine x over sine x. Okay? I have fractions, but I can't add them because I don't have a common denominator. So what I'm going to do is I'm going to find a common denominator. So I am going to multiply this one times the denominator of this one. So sine x over sine x. And this one I'm going to multiply by the denominator of this one. Cosine x over cosine x. I'm getting a common denominator. So I know that I'm going to have two fractions with the denominator sine x cosine x plus, and on the bottom I'm going to have sine x cosine x. On top I have sine squared x, and on top I have cosine squared x. Now, watch how this happens. It's like magic. Some of you are going to want to cancel out. Don't do that yet. Because what I'm going to have is sine squared x plus cosine squared x over sine x cosine x. Here comes the magic. Because this here, let me highlight in a different color. This here is a Pythagorean identity. It equals 1. So I'm going to have 1 over sine x times cosine x, which is really equal to 1 over sine x times 1 over cosine x, which is really equal to cosecant times secant. Times secant x. Okay? So, what do I end up with? I end up with what I want. So I can put a check mark there because that ends up to be exactly what I wanted in the beginning. Okay? I picked the most difficult side first. I converted sine and cosine, found a common denominator, and we're there. This one down here, example 6, looks a little bit more difficult, but we're going to remember that we're probably going to need to have a common denominator. So let's look at this. I'm going to pick this left side here. And what's going to happen is I'm going to say I'm actually going to give myself a little bit more room here because it looks like it's going to be a little bit longer of a problem in terms of writing. And this symbol here is actually a lowercase alpha, just saying, hey, that's another thing that we can use for x. And so 1 plus cosine of a. Okay? Now, I need a common denominator. So I'm going to multiply by the same thing on top and bottom. And I'm picking what I get from the other fractions. So I'm going to multiply this one by 1 plus cosine of alpha. 1 plus cosine of alpha. And let's reduce. This gives me sine squared alpha over sine times 1 plus cosine of alpha plus 1 plus cosine alpha squared, because it's two of them. And on the bottom I have sine alpha times 1 plus cosine alpha. Where do I go from here? Let's look. When I end up actually doing this out, it's going to end up as sine of alpha plus, and let's do a little side note over here. This is 1 plus cosine of a, or alpha, 1 plus cosine of alpha. And so I'm going to do the FOIL here, plus cosine a, and that gives me plus cosine a. And this gives me plus cosine squared a. So I have 1 plus 2 cosine of alpha plus cosine squared alpha. And so when I come down here, I have my common denominator under here, sine alpha, 1 plus cosine alpha, plus, now this here is going to go in for this, so I have 1 plus 2 cosine alpha plus cosine squared alpha over sine alpha times 1 plus cosine of alpha. Whew. I'm tired from writing all that. I'm sure you are too. Let's recap. This is a sine squared up here, okay? Because it's from this fraction up here. We found the common denominator. I expanded this. Now, let's regroup. And when I regroup, I'm going to see that this sine squared alpha plus this cosine squared alpha is actually going to equal 1. So what I'm going to have is 1 plus 2 cosine alpha over sine alpha times 1 plus cosine of alpha. When I move over here, that's 2 plus 2 cosine alpha over sine plus 1 plus cosine of alpha. Now, here comes the trick. There's a 2 in each of these, so I'm going to factor that out. So I've got 2 over, or 2 multiplied by 1 plus cosine of alpha. And on the bottom I've got sine alpha 1 plus cosine of alpha. Hopefully you see what's going to happen right here. So in this purpley color, I'm going to cross those out because it's the same on the top and the bottom. So what I end up with is 2 times 1 over sine of alpha, which is equal to 2 times the cosecant of alpha. I don't know if you saw what just happened right there. It's like poetry. My proof is done because it's actually equal to 2 cosecant of alpha. Okay? Last one. It looks like I've got 2 fractions here that are similarly difficult, seemingly. Okay? But what I'm going to do is I am actually going to pick this one. Start with it. So what I have is this. I am going to try to make the numerator the same. I'm going to be seeing how these two fractions are related on the left side and the right side. I'm going to multiply it by the numerator on the left side. Okay, so I'm going to have cosine t, and you'll see how this trick works out, times 1 plus sine of t, and 1 plus sine of t, because really it's 1, but I'm multiplying it by something over something. This is actually a pretty cool little thing that happens. Okay, so what I end up with is cosine of t times 1 plus sine t over 1 minus sine t squared. Because when I do this actual math over here, and I do my FOIL process, 1 times 1 is 1, 1 times sine t is sine t, 1 times minus sine t would be minus sine t, and sine t times sine t would be sine t. Okay, except this is a minus, so this is going to be plus a negative. Sine squared t. These go away. So I have 1 minus sine squared t. Okay, so that's where this comes from. Okay, now let's look at what actually happens. What I have is, on the bottom, use a different color. I'm going color crazy today. This is a Pythagorean identity. And it's really equal to cosine squared t. Okay? So watch what happens. I've got cosine t, 1 plus sine t over cosine squared t. Well, when I cancel out here, this goes away, the squared goes away, so I end up with 1 plus sine, 1 plus sine of t over cosine of t, which is what I wanted in the first place. Okay? So another trick that we learned is to multiply both sides by the numerator of one of the sides, or multiply the top and the bottom by the numerator of the other side. Okay? So thanks for watching, guys. We're going to talk about this more in class, but make sure you get these down and get those tricks. Try to use them on your homework. All right? We'll see you later.